Hello, I am George Kouzas from Innovats. I will present the Mine.io architecture and digital framework for the digital mine. The main contributors to this presentation is Manos Robogiannakis from HMU, Dimitris Kasimis from Innovats, Paul Hose from Jotne, and Malte Kehl from LTU. Here, at a glance, what we will present to this session. First of all, we will start with the problem statement, challenges that current existing mine industry faces, and the gap. After that, we will continue with our vision, the Mine.io concept, and we will present our approach. The third bullet is the presentation of the high-level reference architecture that developed through Mine.io. We have 3 layers. And finally, we will close with the value and the impact of Mine.io. Before analyzing our concept, we need to understand what happens inside the modern mine industry. Modern mine industry faces some challenges. First of all is the fragmentation of the data. We have a variation of ecosystems across mine sites, and many times we do not have sufficient data. Also, we face limited interoperability between systems and pilot sites. Another point is the increasing complexity of the requirements in terms of environmental, operational, and safety factors. And finally, the increasing need of real-time decision making under harsh and distributed environments. Which is now the gap from the technology point of view. As I mentioned before, we have no data many times, or if we have data, these data are stored in siloed solutions, fragmented, distributed, without any kind of communication between these solutions. We have total absence of unified data governance and standards. And finally, we have inefficient data utilization. All this data, if this data exists, there is no common way how to utilize this data in order to produce added value. Here, all this, what does it mean for the mine operation industry? Means that there is a lack of digitalization of the mine. So, the concept here, the Mine.io project, is to find a clear pathway in order to proceed with a digital transformation of the mine industry. This can be done through a Mine.io platform, through a digital platform that can be interoperable, scalable, and open. Why? To support mine operations and technologies that can serve deployed to the mine operations. And finally, this platform should provide an edge-to-cloud integration for the data and the utilization of this data. Our concept is based on a layered approach. Probably as happens almost to other Industry 4.0 projects. A core part of our approach is the decoupling. We try to decouple the data acquisition, mine infrastructure, and services in a clear layers that this will enable the incremental integration of the new pilots and systems, also to provide and support innovative MineIO technologies, also to support the cross-site and the cross-domain interoperability, and finally to support a set of cloud services. Either these services are proposed by MineIO project, either other external services that can utilize the data through an open, let's say, API. This is the big picture of our approach, the high-level reference architecture. As you can see, on the bottom side, you can see all the technologies that are offered by MineIO project, and all these technologies support basic mine operations, exploration or extraction, mineral processing, and waste management. All this data, the concept of MineIO is to take all this data from these technologies or from these operations, store this data and make available the cloud to other cloud services that offered either by MineIO, as I mentioned before, either other external services. We follow a three-layer approach. The first layer, beginning from the bottom side, is the mine physical operations. The second layer is the MineIO platform, and the third layer is the cloud service layer. Let's begin with the mine physical operation layer. Here we have the generation of the data, the actual work that takes place to the mining operations, exploration or extraction, mineral processing, and waste management, as I mentioned before. Also, in this layer, we have the deployment of the technologies that offered by MineIO, and again, this layer can be divided based on many other Industry 4.0 standards in three sub-tiers. The first tier is the infrastructure, the field tier. Here we have all physical systems, drill rings, IoT sensors, robots, and etc. The next tier is the work cell tier. Here we have the control units, UAVs. And the final layer tier is the pilot tier, that here we have the data pre-processing, the utilization of the technologies that we mentioned before, and finally the connection point with the rest of MineIO platform. The second layer of high-level reference architecture is the platform infrastructure layer. Here we deal with the actual infrastructure that enables all the services, all the flows, the data flows from the edge to the cloud, and so on. We have four main modules here. The first one is the remote sensing. The second one is the data storage and the availability, the big data platform. The third is the interoperability and data models. And finally, the security and the governance. We will proceed with these modules or features. Let's start with edge computing. The edge computing in MineIO project challenges. The main challenge is that need to collect data from different environments with totally different conditions. We deal with environments that have no or limited connectivity. We deal with places that are not so ideal, and so on. The edge computing collects the data. If it is possible, sends this data in a real-time basis to the big data platform. If not, can store this data and send us batches when the internet connectivity is available. This is more or less the architecture of the edge computing. We use many aspects of Industry 4.0 for this component, and it is mainly based to the firewire architecture or approach. The second component of the platform layer is the data storage, the big data platform. Here we have again some challenges: data heterogeneity, different data, sensorial images, 3D points, files, a variety of data, and that this data we should manipulate, store, and make available to the upper layers. Another challenge is that we deal with different data storages, depending on the pilot. Some pilots, some mine industries have its own solution for the data storage. Others that do not have any kind of solution, so we need to support all this heterogeneity in terms of data storage. The third challenge is the lack of interoperability. There is no common access to the data. Also, we deal with the indexing of the data, how this data can be available. Finally, we deal with different types of data in terms of how this data can be sent or received. We have data that follows the streaming path. Also, we have data that follows data batches. This is more or less the big data platform. Again, here we have a layered approach. In practice, a big data platform tries to answer to three main questions. What kind of data do we have? Where these data are stored, and how can we retrieve this data? On the bottom side, we have the storage solutions. After that, we have the connectors layer. This is an abstraction layer where we introduced this layer in order to find a common way on how can we retrieve this data. Because we deal with different solutions, different technologies, so we need an abstraction layer for this. And after that, we have the management layer. Here is the core of the big data platform, where we provide the indexing through the asset cataloging. And through the indexing, we can have a search mechanism and make this data available to the upper services. Of course, we cannot have an architecture, a concept without security. We employ stride threat analysis and D-RED risk prioritization. We employ key clock. Also, for the autonomous machine, we provide DSS security stack based on a strong authentication and encryption mechanism. The final part of the MineIO platform is the interoperability and data model. For this reason, we utilize the PLM module, which is a central, let's say, repository that follows the ISO 10333 standard. You can see some screenshots of the PLM module. Also, with the PLM modules provide an REST API for the seamless machine-to-machine communication, and also enables consistent product life cycle data exchange across heterogeneous systems. Again, the PLM module enables both data streaming and both historical access. So we have these challenges that follows the whole Mine.io platform. Finally, we have, going back to the high-level reference architecture, the top layer of the architecture is the service layer. Mine.io provides a set of services that are on the top of this architecture. These services is the AI models for predictive maintenance, workload scheduling, workflow automation, blockchain traceability, social sustainability, and a set of dashboard and reporting tools. All these services can utilize the data that comes from the edge, stored in the middle, let's say, layer, indexed from the middle layer, and consumed by the upper layer. Also, Mine.io platform, through an API, provides the access to external systems in order to utilize all this data with a different way. Now, closing the presentation with the impact and what finally Mine.io project offers. Mine.io offers improved operational efficiency and reduced downtime via predictive analytics, enhanced sustainability environmental monitoring with continuous monitoring and data-driven resource optimization, data-driven decision-making, scalable and reusable digital infrastructure for future pilots by supporting the seamless integration of new pilots. And finally, enhance data accessibility and discoverability through the asset cataloging, open API, and standardized data models based on the ISO 1033. I don't know if you have any questions. I would like to thank you for attendance.
I'll be the first one to crash the ices. George, thank you for the presentation. My question would be, how do you suppose will be the uptake of this new technology for the mines?
What?
Uptake of this technology.
Good question. The platform mainly tries to be more abstract than the mines, the pilots that we already deployed the solution. We try to be to use the decoupling methodology in order to be more adaptable. For us, as a mine platform, tries to be outside of the data. This means of the structure of the data. This means that we can easily use paths that can support different mine industries and mine operations. It is flexible because we provide an API. This means that new solutions can be adapted to the platform and finally can be part of the Mine.io ecosystem. This is mainly here. It is the scalability and the reusable of the infrastructure and also the open standards that we have to included in our solution in order to be more adaptive to different mine industries.
Okay, thank you for the answer. Any questions that suddenly crop up here?